what are the formulation of suspension? So before that, we will discuss about a definition of suspension. So suspension is a biphasic liquid dosage form containing dispersion of solid fine drug particles. So biphasic is a biphasic liquid dosage form containing finely divided solid drug particles in a suitable solvent, in which these are means what? These solid drug particles are insoluble. So these are insoluble. So now see what happens here. Understand. So consider this is as a suspension. This is our bottle suspension. So here the finely divided, these are so much finely divided that the size of each drug particles is around 0.5 to 5 microns. So you can see it is in the micron, this one. So here is the solvent. Solvent is usually a vehicle. It's a vehicle which carries the medicament or drug particles. So majorly we use water as a vehicle. So these finely divided drug particles are dispersed. These are dispersed. Why you are using the word dispersed? Means they are not dissolved. They are indiffusible, means insoluble. Insoluble. That's why we use the word dispersed. So these are dispersed in this solvent, in which these are insoluble in this. So that's why they make two phases. This is one solid phase. This is the liquid phase. This is the dispersion medium. This is the dispersion medium. This is dispersed phase, in which these finely divided solid particles are dispersed. So this is the definition of the suspensions. In exam, you just write it's a biphasic liquid dosage form containing finely divided solid drug particles dispersed in a solvent, in a suitable solvent, in which these are insoluble. So ideal properties of suspensions are what? It should have a uniform particle size. Each particle size of these drug particles should be uniform, so that uniformity is maintained. One should not be of bigger size and one should not be of some smaller size. These should be finely divided of each of uniform size. And then comes it should be physically and chemically stable. That suspension should be, and it should be redispersible upon shaking to ensure correct quantity of medicament in each dose. So see, when these suspensions are used, the solid particle, they make a sediment. एक तलकट बन जाता है, एक जमावट हो जाता है केक की जैसा, क्योंकि ये सॉलिड पार्टिकल्स है। तो ये सब लोग सारे सॉलिड पार्टिकल्स एक जगह ऐसा एक केक फॉर्मेशन हो जाता है। बहुत दिनों तक जब आप इसको एक रखते हो तो सस्पेंशन, तो एक सॉलिड डिस्पर्स्ड अंदर होके सेटल डाउन होके इधर एक केक जैसा फॉर्मेशन होता है। तो अपॉन शेकिंग, तो एक बॉटल को हम लोग शेक करते हैं तो इट शुड दीज ड्रग पार्टिकल्स, दीज फाइनली डिवाइडेड सॉलिड ड्रग पार्टिकल्स शुड बी रीडिस्पर्स्ड इजीली। सो इजीली बाद में घुल मिलना चाहिए, ताकि ईच डोज correct dose should be given to the patient. So understood na? So these are the ideal properties of suspension. It should have uniform particle size, chemically and physically stable. It should be redispersible upon shaking to ensure correct quantity of medicament in each. Next question is what are the formulation of suspensions? So this is can also be asked like what are the additives used or excipients used in the suspension. So the answer is the flocculating agent, wetting agent, preservatives, suspending agent, organoleptic additives like coloring agent, flavoring agent and sweetening agent. So these are the major additives we use so that we can prepare the stable and elegant suspension. So wetting agent should be added, preservative should be added, suspending agent should be added, organoleptic agent. So in that we majorly discuss about flocculating agents. Flocculating agents we will discuss today. So flocculating agents. So in suspension, the particles should be well dispersed in the vehicle by adding suitable flocculating agent. Dispersion can be enhanced. So suspension में क्या होता है? एक suspension में the particle should be well dispersed in the vehicle. These particles should be well dispersed in the vehicle. So the dispersion can be enhanced by adding the flocculating agent, suitable flocculating agent. So what do you mean by flocculated? So क्या होता है इधर flocculated में? Just first we will understand in English that what is the flocculation. The solid drug is crushed into smaller particles and then dispersed in a dispersion medium in order to prepare a suspension. As a result of crushing, the surface area of particles and their associated surface energy increases. This makes the system thermodynamically unstable with highly energetic particles which regroup and reduce the total free surface energy. So the solid drug is crushed into smaller particles and then dispersed in a dispersion medium in order to prepare a suspension. So हम लोग क्या करते हैं, ड्रग पार्टिकल्स को, बड़े ड्रग पार्टिकल्स को फाइनली डिवाइडेड करके हम लोग छोटे 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 ड्रग पार्टिकल्स बना देते हैं. बाद में इनको क्या हम लोग क्या करते हैं, डिस्पर्शन मीडियम में इनको मिला देते डिस्पर्शन मीडियम में. तो तब क्या होता है, एज अ रिजल्ट ऑफ क्रशिंग, सो पहले इनका सरफेस एरिया ज़्यादा था, अभी क्रशिंग के बाद इनका सरफेस एरिया जो है वो घट गया. तो इसकी वजह से इनका सरफेस फ्री एनर्जी, ये जो है सरफेस फ्री एनर्जी जो है इंक्रीज हो गया. दिस मेक्स द system thermodynamically unstable with high energetic particles which regroup and reduces the total free surface. साइज छोटा होने से सरफेस एनर्जी हो इनका इंक्रीज हो जाता है. पहले बड़े बड़े पार्टिकल्स थे तो सरफेस एनर्जी जो है वो कम था, क्योंकि इसमें एक पार्टिकल में ये 10 पार्टिकल बन जाते हैं छोटा. तो इनका सरफेस एनर्जी जो है इंक्रीज हो जाता है. दिस मेक्स द सिस्टम thermodynamically unstable and highly energetic particles which regroup and reduces the total free surface energy. So these small free particles regroup हो जाते हैं. regroup हो जाने के बाद क्या करते हैं, they reduces the total free surface energy. So this is explained by this formula. So that is change in free surface energy of a solid particle is directly proportional to change in their surface area. So delta A. So this is the free surface energy, delta F. This is the surface area. So delta F, if we remove the proportionality constant, we'll remove the gamma delta A. What is this gamma? This gamma is the interfacial tension between liquid, medium and solid particles. So a suspension can attain thermodynamic stability either by decreasing the interfacial tension or by reducing the total surface area. So now this gamma is the interfacial tension. So you have to decrease the interfacial tension between the liquid, medium and solid particle, or reduce this total surface area. So total surface area have to reduce. So thereby thermodynamically stable suspension can be prepared. So understood na? So next, the important point that we are going to discuss is flocculation forming. How these particles forms the flocculation, that we will understand. Particles are there, no? They regroup and reduces the free surface energy. Therefore the particle dispersed in the liquid suspension form. So therefore the particles dispensed, these particles which are dispersed in the liquid, forms the light fluffy floccules held together by weak van der Waals forces. Now, in the presence of stronger adherent forces, these particles known to form the aggregates. If an adherent force is applied, then they forms the aggregations are there. So that is very undesirable in the suspension. So now we'll discuss that what are the difference between flocculated suspension and deflocculated suspensions. So solid particles form a network which looks like scaffold like structures. So scaffold means these are the scaffold like structures. Earlier scaffold means the wooden platforms like this where the prisons are used to executed. So this is the scaffold. So they look, solid particles form a network in a flocculated suspension. So they combine together and form a network which looks like scaffold like structure. Here in deflocculated suspension, each particle present as a separate entity. Each particle as present as a separate entity. So there is no flocculation or formation of network kind of structures. So this is the first major difference between flocculated suspension and deflocculated suspensions. So particles settle down rapidly. Second difference is particles. The solid particles settle down rapidly, forming bulky but loosely packed sediment. So जो sediment जो formation होता है, so next is जो sediment तलकट हम लोग बोलते हैं ना हिंदी में, जो जमावट होता है. So particles सॉलिड पार्टिकल्स सेटल डाउन रैपिडली, क्योंकि इनकी साइज कंपैरेटिवली फ्लॉक्यूल्स होने की वजह से इनकी साइज़ ज़्यादा रहता है। साइज़ ज़्यादा रहने की वजह से सॉल्युबिलिटी भी बढ़ती है, दे आर इनसॉल्युबल, मतलब उनका जल्दी वो नीचे आ जाता है, वो एक सेडिमेंट जैसा बन जाता है। लेकिन ये सेडिमेंट लूजली पैक्ड होता है, तो लूजली पैक्ड होता है। लेकिन हियर what happens, particles settle down because particles are not forming floccules, so that's why they settle down slowly but forming very closed sediment. Here they settle down rapidly but loosely packed. So this is the second major difference between flocculated and deflocculated. Third one is the unpleasant appearance, or look is not elegant. Here in flocculated, here pleasant appearance. So this suspensions looks nice. These are network-like structures. Network-like structures, they don't look that much nice. So sediment is easily this is the third difference. Next we'll go. So sediment is easily dispersible upon shaking. ये शेक करने की वजह से डिस्पर्शन जो है इजीली हो जाता है. इधर sediment is easily dispersible upon shaking. Here sediment is difficult for redispersion. So इधर ये जो केक जैसा फॉर्मेशन होता है, केक जैसा जो फॉर्मेशन होता है, ये इजीली रीडिस्पर्स नहीं होता है. So here the fifth difference is structured vehicle is necessary to suspend the floccules. Structured vehicle is not necessary. So vehicle इधर एक अच्छा वाला होना चाहिए. फ्लॉक्यूलेटेड में क्या होना चाहिए? सस्पेंड स्ट्रक्चर्ड व्हीकल is necessary. Here structured vehicle is not necessary. So समराइज जो हम लोग करते हैं तो बोल सकते हैं कि हिंदी में कि सॉलिड पार्टिकल फ्लक्यूलेटेड में फ्लक्यूलेशन होने की वजह से दे फॉर्म दी नेटवर्क लाइक स्ट्रक्चर्स. सो उसका अपीयरेंस उतना अच्छा नहीं रहता है. लेकिन हियर ईच पार्टिकल्स इज प्रेजेंट एज अ सेपरेट एंटिटी. सो सेपरेट एंटिटी का प्लेजेंट अपीयरेंस है, एलिगेंट लुक रहता है ये सस्पेंशन देखने के लिए डिफ्लक्यूलेटेड. बिकॉज दे आर पैक्ड, सेडिमेंट इज पैक्ड वेरी क्लोजली. Upon shaking, redispersion is not that much easy. Here they are loosely packed, that's why sediment is easily dispersible upon shaking. So thank you guys, please subscribe to my channel. I'll get you the more videos like this. Thank you.